Hi everybody, this is Teacher Yongma. Okay, we have 2 more minutes until the start. Right, please get your call topic book ready. Okay, we will start in 2 minutes. Okay, we'll be starting in a minute soon, right? Today we're going through 2 more topics on word problems. So please prepare yourself. Okay, it's gonna be a very interesting lesson ahead. So yeah, just prepare your book, prepare your stationaries. Okay, we will start in less than a minute. All right, it's already 5:30 p.m. Right, so let's get started. Hi, everybody. It's Teacher Yonglam again. Today is July 22nd, and we'll be going through another weekly topics live stream. Today, we will focus back on word problems. Right, I'm introducing 2 types of word problems to you, right, just as a form of review. Okay, and as usual, after today's live stream at 6:30 p.m., I will be posting a post-class practice for you all to try out and submit online. Okay, and also this Friday, there will be a new weekly mock test paper. So everyone, please get prepared. Yeah, it's the usual drill. Okay, with that, please get your book ready. We are still going to be going through questions, right, in this book. And without further ado, right, the first type of problem is age problems, right? We have seen this again and again in the mock test, and the accuracy rate is just around that, right? So today we will have a bit drills, right, about some common age problems that you might see in your HAL math exam. Okay, so please turn to page 107. Okay, 5 seconds. 5, 4, 3, 2, 1. Okay, some of you are still flipping, I bet, right? So while you guys are flipping, right, let me just go through some common age facts, right? So let's take a look at this table over here. We have Pip and Bud's ages, and we want to find a relationship between them, right? This year, Pip is 9, right? And Bud is 6. So can you tell me 1 year later, what should I do to each of their ages, right? 1 year later, right? Each of their age will grow older by 1. Good. So I need to add 1 to each of their ages, which means 1 year later, Pip is 10, Bud is 7. Right? Every time a year has passed, I have to plus 1. I have to plus 1. So 10 plus 1, 11. 7 plus 1, 8. Okay, what if I want to go backwards, right? 1 year ago. Obviously, what do you do this time? What do you do this time if you are adding? Sorry, if you're going forward, you're adding. If you're going backward, you should be subtracting, right? So minus 1. Pip was 8 years old last year, and Bud was 5 years old last year. Similarly, if I go another year backward, then Pip will be 7 years old, and Bud will be 4 years old, right? 2 years ago. Now here there are 2 extra columns that you should pay more attention to, right? The first one is the difference between the ages. So let's see, what is the difference between their ages this year, right? 9 and 6, the difference is 9 minus 6, which is, what number is it? 9 minus 6 is 3. Good job. Okay. And then how about 1 year later? 1 year later, will the difference suddenly change? Right? 10 minus 7 is 4. No, right? You realize 10 minus 7, the difference is 3. 11 minus 8, the difference is also 3. Right? Even when we move backward, 8 minus 5 is 3. 7 minus 4 is 3. So what do you notice? Before I move on to the sum of their ages, what do you notice about the difference of their ages, right? It's always 3, right? So the first conclusion that we can have here is that the age difference between 2 people will never change, right? Provided it's between 2 people right? Then your age difference is always the same. Okay, moving on. What about the sum, right? Oh, the bloopers is out, right? It change in the age sum depends on how many people there are, right? So let's see. Look at the sum of the ages, right? This year, the sum of the ages is 9 plus 6 equals 15, right? But then how about the next year? Will it suddenly be 16? Will it be 16? Think about it. Is it 16? No, right? Okay, so it is 10 plus 7. Good. 10 plus 7 is 17. Another year, 11 plus 8, 19. Now, if we move backwards, 8 plus 5 is 13. 7 plus 4 is 11, right? Look at the pattern over here. Every time we pass by 1 year, how many years do we add to the age sum, right? Every time we pass by 1 year, it is a plus. Plus how many, everybody? Plus. Very good job. It's a plus 2, right? So many of you are telling me plus 2, plus 2, plus 2, right? The reason that it's a plus 2 is because Pip's age increased by 1, but age increased by 1. So every year, Pip and Bud will grow old together. Right, so you plus 1, I plus 1, together we plus 2 lor. Next year, you plus 1, I plus 1, together we plus 2 lor. Right, so the most basic two age facts we have, number 1, difference of ages between two people will never change. Second, right, for two people, every year, right, my age will plus 2, or rather the age sum will plus 2. Every year, age sum plus 2. With this, we already can do question number 1, right? In case you forget, it is at page 107. Right, while I'm going through this question, if you already have the answer, please type it in the chat as well. Okay, so with that, are you ready? Let's go. Right, 7 years older, right? David, first of all, is 7 years older than Cindy. Now we have two characters over here, and I tell you 7 years older. Can you tell me this 7? Does that mean David is 7 years old? Like, what is 7 meaning? 7 refers to the age difference, right? 7 years older. So that means when I compare their difference, David is 7 years older. Okay, now moving on. 5 years ago, the sum of their ages was 17 years. So this is the age sum, right? How old is David now? So this time, I didn't tell you any one age. I just tell you their sum and their difference, right? And I'm asking for their ages now. If you have information about the sum and the difference, what do you think you can draw to help you? Like sum and difference. Sum and difference. What can you draw? You can draw your, right? You see sum, difference, or even multiple. The moment you see this information, you should think of a bar model, right? So let's draw a bar model to solve this question. But when it comes to an age problem, a very, very important point to take note is what the time point for you to draw the model for, right? A certain model will only work for one certain year. So which year is it? Should we draw for 5 years ago? Or should we draw for now? That's right, right? Depending on the question, we have to choose our time point very carefully, right? So actually, check the timing carefully. Since the question is asking for how old David is now, let's just draw the model for now, right? We have two characters, David and Cindy, right? So who gets a longer bar? Who should get a longer bar? Oh yeah, okay, I see some answers already. Are you sure? Yeah, it is right. So David is the longer bar and Cindy has the shorter bar. And now we need to label some information, right? First of all, you look at the difference is 7. David is 7 years older than Cindy. Now you know the age difference will never ever change. That means when we label the difference, this extra part is always going to be what years? What should I label as the difference, everybody? The difference should be? Yes, the difference should be 7. Okay, yeah, because the age difference never changed. Now, I also know their age sum, so let's label their age sum. Is it correct to say their age sum is 17? Can I say their age sum is 17? I see a lot of you say 17, 17. Is 17 the age sum? No, because remember, 17 was their age sum 5 years ago. 5 years ago, their age sum is 17. Now I want to find their age sum now. From 5 years ago, right? Let me write it down. From 5 years ago, I want to reach now. how many years will each person's age increase by? It will increase by, right? So does that mean I should just do 17 plus 5? Can I just do 17 plus 5? I mean, 5 years have passed, so I will add 5 for one time. Am I correct? Am I correct? No. Why? Because remember, 5 years have passed, you grow older by 5, I will also grow older by 5. So 2 people each grow older by 5 years. So 17 plus 5, you have to plus 5 again. Right, this is for David, this is for Cindy. So this is a commonly mistaken part, right? Please take note, right? 2 people, 5 years later, each of them will grow old. So I need to add 2 times. So then 17 plus 5 plus 5, the actual sum is 27. Okay, so now you know the actual sum and actual difference, right? You know that these two parts should be the same, right? 1 unit and 1 unit. So then we can find out what is the 1 unit, right? 27 minus 7 equals 20, right? But that's 2 units. So to find 1 unit, you will do 20 divided by 2, which is equal to 10. Okay, finally, is my answer 10? Can I say my answer is 10? 1 unit ma. Okay, the moment you find your 1 unit, regardless if it's sum difference multiple or like working backwards or age problems, look back at what the question is asking, right? You found your 1 unit, it's now time to look at the question. It's asking, how old is David? So David is not just 1 unit, David should be a 1 unit 10 plus 7, and that will give me 17, which is correct, right? 17 is the correct age of David, right? I see a lot of you say 17, 17, 17. Very good job. Okay, please take note. Read the question properly. Now, let me repeat. In an age problem, the most important thing when you draw the model is to be very clear what time point you should draw for. Right? If it's a sum and difference problem, yeah, it's still okay, right? But what if I have a new information? Right? Let's take a look at this table, right? So let's say a long, long time ago, right? Teacher Ollie and Teacher Yonglam are comparing their ages. 2 years ago, Teacher Ollie is 8 years old. Teacher Yonglam was 2 years old. So that means Teacher Ollie is how many times my age? 8 is how many times of 2? 8 is how many times of 2? Right, everyone should know it. It is 4 times. Good job, right? Now, how about 1 year after, right? Last year, Teacher Ollie should be, now plus 1 to her age, 9. Teacher Yonglam should be 3. Now, this time, are we still having a 4 times multiple relationship? Is 9 really 4 times of 3? How many times of 3 is it? Yes, it is 3 times, right? 9 is 3 times 3, so it's 3 times. Okay, and you see the multiple relationship is different now. Okay, so let's continue to find the ages now, right? Now, Teacher Ollie will be 10, Teacher Yonglam will be 4. And do you see any multiple relationship? Can I say 10 is something times 4? Well, there's no whole number multiple relationship, unfortunately, right? So you don't even have a multiple relationship every single year. Okay, now another year later, Teacher Ollie will be 11, Teacher Yonglam will be 5, right? And again, there is no multiple relationship. Do you think there will ever be a time again when we have a 4 times multiple relationship? Do you think there will be another time where you see 4 times or 3 times? Yes or no? Think about it. Actually, the correct answer is there will never ever be another year where our age is 4 times, right? Any age multiple relationship only appears for 1 year, right? It only appears for 1 year. So in other words, whenever you see a multiple relationship, it is very, very rare, and you should always consider that first, right? Whenever you see a multiple relationship, the model will be easier to draw. So please draw for the multiple relationship first. Okay, now let's take a look at question 2. It's at page 110. Right, this year, the sum of ages of Mike and Candy is 78. Right, this is the sum this year. Now, 6 years later, Mike will be 5 times. I have a multiple relationship. Mike will be 5 times as old as Candy. Now, we want to find the age of Mike and Candy this year, right? So over here, you see that we have 2 time points, right? This year and 6 years later. So before we even draw a model, we need to figure out, whoa, what time point should we draw for? Okay, And apparently this question already said I should draw for 6 years later. Do you know why? Do you know why it should be 6 years later? Right? What is so rare on the 6 years later that we should definitely draw for it first? Now read the question again. 6 years later, Mike will be 5 times as old as Candy. You see there's a multiple relationship, right? Whenever there is a multiple relationship, we need to focus on it first. It makes our model easier to draw. So find the timing with a times relationship and draw based on that, right? So we know 6 years later, Mike will be 5 times as old as Candy, right? So Candy will be my 1 unit. Mike will be my 5 units, right? 1 unit, 5 units. Okay, very good. So you see, with this, we can figure out more of our information, right? Because it's just not just one long bar, one short bar. Okay. But now the question also gave us the age sum, right? So let's figure out what is the age sum. This year, their age sum is 78. But what about 6 years later? What will their age sum be 6 years later? Right? Is it still 78? Right? If you know the age sum 6 years later, please type it in the chat. Is it 78? If it's not 78, then what is it? What is it? Okay? Right. So you realize that this year is 78. 6 years later, Mike will grow by 6 years. And Candy's age will also grow by 6. So it's actually 78 plus 6 plus 6 equals to how many? How many? 78 plus 6 plus 6. Very good job, right? Some people are chatting very furiously. It's 90, right? So that means you have 1, 2, 3, 4, 5, 6. 6 identical units, and this 6 units is equal to 90. So straight up, you can find out what is 1 unit. 1 unit is 90 divided by 6 equals 15. Okay, so now we found that 1 unit is 15. So that means Candy, 1 unit is 15, right? Mike, 1, 2, 3, 4, 5. 5 units is 5 times 15 equals 75. Okay, is teacher Yonglam correct? Is teacher Yonglam correct? Can I just say, hoo, I found 15 and 75, right? They asked us to find each of their ages, what? Right, am I correct? Wow, hopefully you guys are screaming at the screen now, right? 15 and 75 are not correct. Remember, why we choose to label the time on the model is so that we remind ourselves, whatever information we find here is referring to 6 years later. But actually, the question is asking us to find what are their ages this year. 6 years later, I have 15 and 75. But I want to find this year, so we are going back in time. So how should I adjust their ages? Is it 15? 6 years later is 15. This year is 6 years ago, right? So I need to plus 6 or minus 6. Right, some people are typing in the chat. Good job, right? It's 15 minus 6. 15 is 6 years later. That means this year it's 15 minus 6 equals 9. For Mike, 75 is 6 years later. Same thing, I will minus 6 and I will get 69. So that means Mike is 69 years old and Candy is 9 years old this year. You can check, right? The age sum is indeed 78. Okay, so my answer is Mike 69, Candy 9. Okay, any questions so far? All right, so if you are confused, it's okay. The playback is always available, or you can talk to me, right, on the group chats later. Okay, so with that, hopefully whenever you see age problems, you know, right, your model, you must pay huge attention to the time point with the multiple relationship. All right, now with that, let's perhaps review with yet another question, right? Are you ready? Right, this time this question is on your next page, right? Page 111. Let's read the question. When Daryl was 6 years old, his father was 34 years old. Now, I give you the ages directly. I am so generous, right? However, there is yet another clue. Now, his father is 3 times as old as Gerald. How old is his father now? Okay, what's the most important information for you to draw the model? Right, you have your 6, you have your 34, but that's just a specific age at a specific time point. it doesn't help us at all. Or does it? I'm not sure, right? At least if we want to draw a clearer model, there's another clue that could help us. What clue? 28, 28, what is 28, right? Okay, we'll come to that later. But I see a multiple relationship. Aha, whenever we see a multiple relationship, right, we should definitely draw for the times relationship first. 3 times. Do you know when is the 3 times? At what time point is there a 3 times? Yes, it's now. So actually, I shouldn't say some year. I know the exact year. It is now. Okay, so now father is 3 times as old as Daryl. So Daryl is 1 unit. Father is 3 units. Okay, and now can teacher Yong Lam still find the 8 sum? I know 6 plus 34 ma, right? 6 plus 34 is 40. Yay! My age sum is 40. Does it work like that? Unfortunately not. Because 34 and 6 does not have a 3 times relationship. Some years must have passed. But you don't know how many, right? You don't know you need to plus how many to each of their ages. So it's impossible to find their age sum. However, you know that the father is 34 years old and Daryl is 6 years old. Something will never change, right? What will never change? What information can you also use? What information can you also use? Aha, right. You realize that if the sum cannot work, let's check the difference. Daryl is 6, father was 34, right? Can you tell me what is the age difference? The age difference, simply subtract, right? 34 minus 6 equals what, right? Who is quick at calculation? 34 minus 6 is, that's right, good job, 28, right? The age difference is 28. Now, why am I particularly interested in the age difference? It's because no matter how many years have passed, right? 100 years, 10 years, 1,000 years, as long as they're still alive, yeah, the age difference will never ever change, right? That means when I have this 3 times relationship between these two people, the age difference will still be 28, right? So now you know the age difference is 28, which is just nice 2 units, right? 2 units is 28. So of course I can find out 1 unit is equal to 28 divided by 2, which is equal to 14. And remember, the question is asking whose age? Whose age is the question finding? It's finding how old is his father now? Now, the father is 3 units as the age. So 3 units is equal to 3 times 14 equals 42, right? And that is how I get my answer, 42. Okay, so if the sum doesn't work, but there's a multiple relationship, the difference, right? The age difference between 2 people will never change. Okay, so yeah, what does whatever stand for, right? So pay attention in class. Thanks. Okay, so with that, we have looked at sum and multiple, sum and difference, difference and multiple. Are there some more funky age problems? There are, right? So let's look at the next question, right? It's in page 113. Are you ready? Right, let's read the question together. This year, Ryan's mom is 46 years old, and her 2 kids are 8 and 12 years old, respectively. How many years later, mom's age is exactly the same as the sum of the ages of her 2 kids? Now, this time, am I still comparing the ages of 2 people? Am I still comparing? You're not done? Oh, it's okay. Right, just look at the next question first. Right, I will send the playback later so you can look through at it. For now, most importantly, listen to me while I go through the question. Right, now, I am actually comparing a mother's age, right, a mother's age with her 2 kids. I am not just comparing between 2 people. Instead, I am comparing between group 1, group 2. 2 groups of people. In this case, I would recommend you draw a table to find the pattern, right? Because previously, when we draw our bar model, 1 bar is for 1 person, 1 bar is for 1 person. But here I am comparing mom's age and the sum of the 2 kids' ages. So I am not comparing 1 to 1, I'm comparing 1 person to 2 people as a group. right? So if we are comparing between groups, please draw out a table, right? It could help you to, find the pattern more carefully. Okay, so with that, let's take a look at this table. Now, I have already listed out, right? Mom's age this year is 46. How about the two kids, right? I am comparing with the sum of the two kids' ages. This year, they are 8 and 12 respectively. That means their sum will be 8 plus 12 equals 20. Okay? Now, actually over here, I will need to compare their differences as well, right? So let's compare their difference. Mom is 46, kids is 20, so their difference is 46 minus 20 equals 26. All right, now this is what happens this year. Now, moving on to next year, you will notice that will the difference change this time? Previously, when I have two people, right, just two people, their age difference will never change. But here I have two groups of people, right? Mother is one person. Two kids is, two people. Will their age will their age difference change? Let's see. Mother gains 1 year older, so the mother will be 47 years old. The two kids, right? However, the first kid will gain 1 year older, second kid gain 1 year older, so plus 1 plus 1. So actually, the new age sum is 20 plus 2 equals 22. Right, what's the age difference? Do you think the age difference is 46 minus 20 equals 26? Right, 47 minus 22 is 25, right? 47 minus 22 is 25. All right, so in that case, then it's a bit different, right? You notice that the age sum, or rather the age difference will decrease by 1. That is because my two kids' ages grow faster, right? Grow by 2 every year. Grow by 2 every year. My mother's age grow by 1 every year. So 2 versus 1. Of course, eventually, right, your two kids' ages will catch up with the mom's age. Okay? So let's consider the next one, right? 2 years later. So let's add another one. 2 years later, the mother will be 48 years old. And, right, another year, another plus 1 for the kid 1, another plus 1 for kid 2. So the total age of the two kids is now 22 plus 2, which is 24. So then their age difference is now 48 minus 24 equals 24. And you realize their age difference decreased by 1 again, right? So starting from an age difference of 26, every year the age difference will decrease by 1, decrease by 1, decrease by 1. But when do we want to stop? The question is asking how many years later mom's age is exactly the same. Now, if I have two numbers that are the same, can someone tell me what is the difference between their ages? If I have two people with the same number, two same numbers, what should their difference be? Their difference should be 0, correct? Right, same number, there's no difference. The difference is 0. So from an initial age difference of 26, I keep on minus 1, minus 1, minus 1, until I want the age difference to reach 0. Right, how many years does it take to achieve the difference of 0? Right, what's your answer? Everyone type down your answer. Is it 27? Pay attention, right? Is it 27? Okay, from 26 to 0, in total, I need to decrease by 26. Every year I decrease by 1. So it's 26 divided by 1. Total decrease is 26. Every year decrease by 1. So 26 divided by 1 equals 26. So it is 26 years later. All right. Now, the key difference in this problem is that we are not comparing the ages of two people. We are comparing between two groups of people. If we are comparing between two groups of people, perhaps the model isn't the best choice, but try to figure out the trend of the difference, right? How does the difference change as we move on from 1 year to the next? Okay, yeah, so the answer is 26. Okay, so what happens if you have 3 people, right? Then will the trend be like this as well? This, I will leave it to you for the exercises. All right. Okay, so with that, are you ready for the next question? The next question is something new, right? We are not using models or whatever. Right, let's see. Anna and Belle are cousins. Oh, this is page 115, by the way. This is page 115. Okay, Belle is 58 years old this year. Okay, pay attention. This is a new question. This is new. Please pay attention. Okay. Belle is 58 years old this year. One day she asked about Anna's age. You don't know Anna's age, but Anna just said, I was 20 years old when you were my current age. Okay, so how old is Anna this year? Okay, so this question is a bit tricky because I did not directly tell you the two people's ages directly, right? Instead, I tell you what happens when I go to another time point, right? So if you have any changes in time, right, what I would like to use is a magic arrow. And this is what we call a when age problem because there's a very important keyword here. When, right? I was 20 years old when you are my current age, right? So you notice that the two of them are like traveling back in time or traveling forward in time, right? So let me ask my first question, right? Do you think Anna is younger or older than Bella? Right, please type in the chat. Let me know, what do you think? Do you think Anna is younger or older than Bella? Is Anna older or younger? Wrong page, 116. Oh, right, thank you. It's 116. Okay. Is Anna older or younger? Yes. When you were my current age. So this is actually a past tense, right? That means they are traveling back in time. If Belle were Anna's current age, that means Anna should be younger, right? So Anna is younger. How does that help us to solve this question, right? Let's draw a magic arrow or a timeline to solve this, right? Then we label their current ages first. Okay, so Anna is here. You don't know how old is Anna, but you know, Belle is here, right? She's older. She's 58 years old. Okay, now, how do we show time traveling? Right, so I was 20 years old when you were my current age. So originally, this year, Belle is 58 years old, right? Then now we want to make Belle's age into Anna's current age. This is Anna's current age. When Belle was Anna's current age, what I do is I travel back in time, right? Imagine there's a time machine. Ooh, I travel back in time. For how many years? I don't know. I will label using a triangle, right? So triangle years ago, Belle was back to Anna's current age, right? So this is Belle at the past. Okay, so you can label here. This was Belle at the past. Now question, did Anna still stay the same age? When we travel back in time, Belle is younger. How about Anna? How about Anna? Will Anna suddenly stay at the same age? No, right? Anna will also be younger, right? Younger by how much? Should be the same change, right? They all travel back by the same number of years, right? We time travel them for the same number of years. And now Anna comes to the past. And what do you know? At this past time point, Anna was 20 years old, right? So we can label Anna was 20 years old. Okay, so there you have the picture, right? And we are asking how old is Anna this year? We want to find this age. Now, what do you notice? Can you use 46 minus 12 minus 8 for question 4? No, cannot. Question 4, 46 minus 12 minus 8 is just a coincidence. Okay, thanks for pointing it out. Okay, here I have 20 and 58. And at least I know there's a gap of 58 minus 20 equals to 38, right? 58 minus 20 is 38. So the gap from Anna's past to Belle's present is 38, okay? But now, right, I have two triangles, right? If you look at the number line, your total gap of 38 is comprising of, or it contains two triangles, and they are equal, right? Because each of them are traveling by the same number of years. They are traveling by the same number of years, so you know 2 times the triangle is 38. So how much, or rather how many years is one triangle? One triangle will be 38 divided by 2, which is equal to 19. Right, so 19 years have passed. 19 years have passed. So how can you find the point over here. How can you find this age next? We can just use the fact that 19 years have passed. So what's the answer? 19 years have passed. Okay, so you can either start from here, 20, grow older by 19, right? 20 plus 19, or starting from 58, go back 19 years. 58 minus 19. Either way, they should give you the same answer, which is 39, right? So that means Anna is 39 years old this year. Okay, right. So with that, that is how you do this question, right? How cool, so many stickers, very interesting, huh? Okay, so with that, this is how we do a when age problem. Whenever you see a question where they need to travel back in time together, and when someone's past is equal to the other person's current age, think of the timeline and you let them time travel. Okay, whether it's forward or backward, it requires some English. All right. So with that, that is part 1 of the word problems, right? I have just gone through topic 10, which is age problems. Now let's move on to another type of problems, which sounds pretty much like age problems, right? In fact, it rhymes, right? It's just an extra letter, right? Everyone's favorite page problem, okay? Now, what exactly is a page problem? Everyone still remember that? Okay, so actually I see that a lot of papers, right? The mock papers, the page problems accuracy rate is also around that, right? So let me have a brief recap with you on page problems. Okay, with that, let's take a look at a warm-up, right? So first of all, let's start with some baby warm-up questions, right? How many digits are there in the numbers 1 to 9? This one easy. How many digits are there in 1 to 9? Now, 1 to 9, these are all my, what do you call that? You call them my 1-digit number, right? So I can classify all of them to my 1-digit numbers. 1 to 9 is my 1-digit number, right? And of course, there are 9 such numbers. So 9 numbers, how do I find the number of digits? 9 numbers, every number has 1 digit. So 9 times 1 is equal to 9. Okay, so 9 times 1 is equal to 9. So you know from 1 to 9, there are 9 digits. All right. Now, how about the next one? How many digits are there in the numbers 1 to 99? I know 99 numbers, so my answer is 99. Is my answer 99, yes or no? Is my answer 99? Pretty sure it is, right? But you need to take note. A lot of you are shouting at me now. It's not 99 because 99 itself is a 2-digit number, right? If I said I have 99 digits, that means every number 1 digit, every number 1 digit. But I have some 2-digit numbers over here, right? After 1 to 9, my next number 10 is already a 2-digit number. 10 to 99 are all 2-digit numbers. So how many 2-digit numbers are there? I know 99 minus 10. Is it 99 minus 10? No, what? Right, 99 minus 10. By minus 10, I am taking away the first 10 numbers. 1 to 10. But here I include 10. So technically, it should be 99 minus, bloopers, 99 minus 10 plus 1, right? Which means there are 92-digit numbers. I have 92-digit numbers. Each number has 2 digits. So what is the total number of digits I have? 90 numbers, each number 2 digits. So it's 90 times 2, right? And 90 times 2 is 180. Okay, but don't forget, I'm asking 1 to 99. 1 to 99, we will need to add up the total digits here. So 9 plus 180. Therefore, you have 189 as the total number of digits, right? From 1 to 99. Can follow so far? Can follow so far? Okay, if can, then let me amp up the difficulty a bit, right? How many digits are there from 1 to 999? Just now we added 99. From the next number onwards, 100, right? 100, 101, these numbers are way bigger, right? In fact, they are my 3-digit numbers, right? They are my 3-digit numbers. So if they are my 3-digit numbers, let's see, starting from 100 to 999, they are all my 3-digit numbers. How many are there? So again, remember the rule, end minus start. But remember to plus 1. This will give me the number of consecutive whole numbers. right? So I see some of you already remember the magic number. Yes, good job. So yeah, it's over here, right? Why do we get that? It's because from 999 to 100, we have 999 minus 100 plus 1, which is 900 three-digit numbers. Now again, I have 900 three-digit numbers. Each number has 3 digits. So 900 times 3 is equal to 2,700, right? So my 3-digit numbers will contribute another 2,700 digits. So altogether from 1 to 999, we have 9 plus 180 plus 2,700. The total is 2889 digits. Okay, so here there are 3 very important numbers. 1 to 9, 9 digits. 1 to 99, 189 digits. 1 to 999, 2889 digits. Okay, test your memory. 1 to 9, how many digits? 1 to 9, 9 digits. 1 to 99, 189 digits. 1 to 999, 2889 digits. Right, so that please remember these numbers. Alternatively, I could combine them into a number line, right? Pages and digits, right? So let's draw out a number line. Imagine this like you're watching a YouTube video. Well, you are watching a YouTube video now. So the YouTube video that typically starts from the left, then goes all the way to the right, right? So it's like a progress bar as you watch the video. So let's just say I start from the first page, right? My first page will be the first digit, right? And then we start off with my 1-digit pages. 1-digit pages will end at 9, right? So there are 9 digits altogether. Okay, then we continue to the next part. After teacher Yongla finish my 1-digit numbers, I will have my 2-digit numbers, right? All the way up to 99. Okay, so please draw this with me together, right? All the way up to 99. Okay, and how many digits did we use? Is it 99? No, it's 189. So 189 digits. All right, and then we have our 3-digit numbers, right? So it ends at 999. Take note, whatever I enable on top is the number of pages or the number of whole numbers. So of course, 1-digit number is 1 to 9. Then 2-digit numbers is up to 99. 3-digit numbers up to 999. Everything I label over here is about the whole numbers. And everything I label in the digits is referring to the number of digits taken to reach this specific checkpoint, right? So then for 999, right, from 1 up to 999, I would have written a total of 2889 digits. So this is the structure of page problems, right? 1 to 9, 1 to 99, 1 to 999. I would like to call this a progress bar. Okay, so we will have this number line, which is very useful. It gives you some useful checkpoints to figure out the relationship between your pages and your digits. All right, so it's already 19 minutes left. Originally, teacher Yonglam plans to go through 6 questions, right? But I believe I can skip some easy ones, right? Let's just directly look at some hard ones. With that, let's take a look at question 7, right? Question 6 is still pretty easy, right? Because I only have 68 pages, right? It's a 2-digit number of pages. It's okay, right? You can try yourself. But let teacher Yonglam just use one question, right? One harder question to go through with you this type of page problem, right? The easiest type, which is given the number of pages, count the number of digits. Right, I am at page 201. Okay, I'm at page 201. Now, an encyclopedia has a total of 216 pages, starting from page 1. That means, right, I will have printed page 1 to 216. Page 1 to 216. Okay, how many digits are used to print the page numbers altogether? So let's say I start from page 1. 1, 2, 3, 4, up to 215, 216. There are 216 numbers. How many digits did I use on all these numbers? How many digits have I written? So can I say, aha, it's just 216 digits, hee. Hey, definitely don't say it's 216, because as you would assume by now, some of the pages are 1-digit numbers, some of the pages are 2-digit numbers, some of the numbers are 3-digit numbers, right? So you have 1 digit, 2 digit, 3 digit to consider. All right. So if you have different types of numbers, each with a different type of digit, please make sure you classify them well, right? We need to think in groups, case by case, right? So here there are 3 different classes. You have your 1-digit numbers, you have your 2-digit numbers, and you have your 3-digit numbers. Okay, for each type of numbers, we need to find out, right, how many such numbers are there and how many digits did I use for each category. All right, so with that, let's look category by category, starting from the easiest, which is a 1-digit numbers. Now, can y'all tell me 1-digit number, how to do 11? I'll go through that later. Okay, 1-digit number, what is the range? Of course, I start from page 1 to 9, right? I have included all my non-zero 1-digit numbers. From 1 to 9, how many numbers are there? How many numbers are there? There are, yes, good job, 9 numbers. 9 numbers, each of them use 1 digit. So 9 times 1, there are 9 digits in total. All right, now let's move on to the 2-digit numbers, right? After 9, I will write page 10, and 10 is a 2-digit number. So I keep writing 10, 11, 12, 13, 14. Where do I stop? From 10, where do I stop? Right, where are my 2-digit numbers? Is it all the way to 216? No, right, I went through every 2-digit number up to 99. Right, so 10 to 99 are my 2-digit numbers. At this point, you might have already guessed what's going to happen next. Right, so 10 to 99, how many numbers are there? I know 99 numbers, correct or not? No lah, 10 to 99. Okay, 10 to 99, I know 99 minus 10. Is this correct? Remember what I said, 99 minus 10, you need to plus 1, right? Ending minus starting plus 1. This will give you the correct number of pages, right? Which is 90. Okay, so I have 90 pages in total. Each page is a 2-digit number. 90 pages, each page 2-digit. So in total, 90 times 2 is equal to 180 digits. Altogether, there are 180 digits. Okay. All right. So now let's look at my 3-digit numbers. 3-digit numbers. After 99, I will go to 100. Right. So does that mean I have 100 all the way to 999? 3-digit numbers, we just listed everything, 100 to 999. This is where it's the last category. Please read the question carefully, right? There are 216 pages altogether, so I only stop at 216. Okay, then 216, I need to minus 100 to get the number of numbers. But then don't forget to plus 1. Right, 216 minus 100 plus 1 is equal to 117. Okay, so then this time 117 numbers times how many digits per number? 117 times how many digits per number? 117 times, it's 3 digits per number, right? So this time I have to times 3, right? 117, 3-digit numbers, each number times 3. So my answer, 351. Okay, now is my final answer 351? Right, I found out the total number is 351. Am I correct? No, I am finding the total number of digits, total number. So it is 9 plus 180 plus 351. Right, 9 plus 180 plus 351 equals, that's right, it's equal to 540. Good job. Right, some of you are shouting your answers in the chat. Right, the answer is 540. All right, now in that case, we are done with the first type of question where given the pages, we need to count the digits. Okay, but sometimes the question will ask you to work backwards. Right, let's take a look at this question. This time, I tell you a page number, all the page numbers of a book uses 222 digits. Here is digits. here is digits. 222 is the number of digits. And then the final page number is a what number? So just now I gave you the number of pages. You need to find the number of digits, right? Just now is pages to digits. Now it is digits to pages, right? So then digits to pages, let's figure out how to do that. To do this, you need to remind yourself of the progress bar just now and all the checkpoints. Okay, so with that, here, remember, 1-digit number, you use 9 digits. 2-digit number, 189. 3-digit number, 2889. Okay, so in that case, if I use 2 digits, then how do I find out the final page number? Well, let's just imagine Teacher Yonglam is running on the YouTube progress bar, right? Starting from the left, he needs to run until he reaches 222 digits. So let's see, did Teacher Yonglam finish the 1-digit bar? Did Teacher Yonglam finish the 1-digit bar? Of course, right? 9 digits used only. Now, did Teacher Yonglam finish the 2-digit bar? Up till he finished all the 2 digits, he used 189. Okay, then he has to keep continuing until he reaches 8222, which is obviously way smaller than 2889. So 222 digits is somewhere over here. Okay, so that means my last page number must be a 3-digit number. So I need to continue from 99. How many extra numbers are there? Right, so if we are working backwards, given the digits we want to find the page numbers, please make sure, right, you find the correct number of digits for the last page number first. All right, now with that, I'm skipping question 8 as well because the number is small, you can do it. But question 9 is a bit more difficult, right? Let's take a look at question 9. It is page 205. Page 205. Are you ready? Okay, now with that, let's take a look at the question. A book starts from page 1 and uses 519 digits altogether. This time, I have given you the digits and you want to work backwards to find the number of pages. Right, so working backwards. So remember, you need to find out where is my last page. Is it a 1-digit, 2-digit, or 3-digit number? So how many pages does the book have? Given digits, find pages. First, you need to ask yourself, the last page has how many digits? Right, please answer me. The last page has how many digits? How many digits does my last page have? Right, if you need some help, remember you have a checkpoint. Right, so where is 519? Did we finish all the 1-digit number? Did we finish all the 1-digit number? Yes, we finished, right? Did we finish all the 2-digit numbers? Yes, we finished. Did we finish all the 3-digit numbers? No, right? 519 is somewhere in the middle, right? Which means the last page has only 3 digits. Okay, so please importantly, right? Remember your important checkpoints, right? 1 digit, 9 digits in total. 2-digit numbers, when I finish 1 to 99, 189. 3 digits, right? 1 to 999, 2889. Okay, so now let's look at each progress bar. The 1-digit numbers, I'm done. I'm finished from 1 to 9. Then 2-digit number, I finished up to 189. So I finished all the 99 pages from 1 to 99. Right, so 1 to 99 pages, done. But I didn't complete my 3-digit pages. So Teacher Yonglam need to ask you, right? How many more digits, how many extra digits did I write for my 3-digit numbers? Right, how many more digits? Let's see. How many more digits? Starting after 189, right, up to 189 digits is my 2-digit pages. The next digit onwards, it will be my 3-digit pages. How many more digits did I write for my 3-digit numbers? That will be 519 minus 189, right? Which is 330 digits, right? So 330 digits is used on my 3-digit numbers. Now, does that mean I have 330 pages? Does that mean I have 330 pages? No, take note. over here, every page takes up 3 digits. 3 digits, 1 page, 3 digits, 1 page, 3 digits, 1 page. In total, I have 330 digits. So that's how many pages? That will be 330. 3 digits for each page. So 330 divided by 3 equals 110 pages. Right, so that means on top, I have an extra 110 pages. Okay, does that mean my answer is 110? Does that mean my answer is 110? No, 110 is just my 3-digit pages, but don't forget I'm starting from page 1. So I already finished page 1 to 99. Already I have 99 pages. On top of that, I have written an extra 110 pages after. So total number of pages is, final step, 99 plus 110 is 209. Answer, 209 pages altogether. Okay, so whenever you do page problems, particularly working backwards, right, given digits, find pages. When you are dealing with this type of problem, please remember, right, this checkpoint or YouTube progress bar, right? The first thing to do is to figure out your last page has how many digits. Okay, now with that, let's look at our next type of question. Now this one is about pages and digits, right? But now we are looking at another type of questions where I give you a range and I want to count how many digits, how many times a certain digit appeared. Okay, we have 2 more questions to go. Let's hang in there. Now, let's look at this number table. This number table consists of numbers from 1 to 99. And my first question is, from 1 to 99, digit 1 appears how many times? Okay, let's count. How many times did digit 1 appear? Instead of counting like blindly 1, 2, 3, 4, 5, 6, row by row, it would be a good idea to count by the place values. So how many times did it appear in the ones? How many times did it appear in the tens? Okay, let's go. So how many times did the 1 appear in the ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times at the ones. Okay, how many times did it appear in the tens? Let's count, right? Tens, look at starting from 10, right? 1 at the tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, 10 times. Oh, 10 times at the tens. So in total, digit 1 appears how many times? 20 times, right? 10 at the ones, 10 at the tens. 10 at the ones, 10 at the tens. So in total, 20 times. Okay, how about digit 8? Digit 8, let's look. How many times did it appear in the ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You get the drill, right? For the ones, it appears 10 times. For the tens place, right? 8 appears in the tens place for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, 10 times. So in total, 10 plus 10, it is still 20 times. All right. Now, how about digit 0? Does that mean digit 0 is also 20 times? It looks like every time it is, 20 times. Is it 20? No, right? Because take note, can 0 even be in the tens place? Cannot, right? 0 cannot be at the highest place, so get out, right? But look at the ones place, right? So it will be, let's use a pink this time. 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 appears 9 times at the ones, none at the tens, so the total is 9 times. Okay, so with that, yeah, please take note. From 1 to 99, right, if you don't have your hundreds digit, all digits except 0 will appear 20 times. Okay, but 0 is special, right? It appears 9 times. Now, this is if you don't have a hundreds digit, right? But if you have a number hundreds digit, something's different that's going to happen, right? So let's look at digit 1. From 100 to 199, digit 1 appears how many times? Same thing, right? Look at your red ones. They appear at the ones place 10 times. Look at the blue ones. They appear at the tens 10 times. So is my answer 10 plus 10? 10 plus 10 equals 20. This time, is it still 20 times? 100 to 199. Did my 1 only appear in the ones and the tens? No, right? Because you see every number, 1 is at the hundreds, 1 is at the hundreds, 1 is at the hundreds. All these numbers have 1 at the hundreds place. So how many times does 1 appear in the hundreds? It will be 100 times. So it's an additional 100 times. So pay attention to the hundreds place. Okay? But digit 8 is not at the hundreds place, so don't worry, it is still 10 at the ones. Wow, I can't draw. It's still 10 at the ones, 10 at the tens, right? So it's still going to be 20 times. Okay? And digit 0, since your tens place is not the highest place anymore, so it is also 10 at the ones. Oh, sorry, this is 10 at the tens, 10 at the one, 10 at the ones, 10 at the tens. It is still going to be 20 times. So please make sure you count 100 by 100. 1 to 99, right? Count 1 to 99. How many times did it appear? 100 to 199. How many times did it appear? Right, and then count by the place value. Hundreds, tens, and ones. Pay attention to what is the hundreds digits. All right. So with that, let's take a look at there's a typo. Where's the typo? No, there's no typo, no worries. Okay, now with that, this is a simple one because at least I didn't go to the hundreds, right? How many times does the digit 8 appear in the numbers from 1 to 80? Now this is page 206. Let's take a look, right? So remember, when we are counting, don't just count blindly 1, 2, 3, 4, 5, 6, 7, 8, don't need. Remember to count by the place values. So since this is 1 to 80, right? Thank God there's no hundreds place. But if there is a hundreds place, yeah, you need to pay attention, right? Count 100 by 100. So since this is only 1 to 80, I only need to consider the ones place and the tens place, right? How many times did 8 appear in the ones place? So when is the first time 8 appears in the ones place? Is it 18? Is it 18? No, right? It is 8, right? So 8 is the first time where we see 8 as the ones digit. Then 18, right? List out every time you found a new number, list it out, right? 28, 38, 48, 58. Take note of the range. I need to stop at 80. 68, 78. Okay, do I need to include 88? Do I need to include 88? The answer is no, right? Because I only stop at 80. So I don't need to include 88. So in total, 8 appears 8 times at the ones. Okay? Now, how about the tens place? How many times the 8 appears in the tens place? 80 something. Now, the only case is 80, right? 80. Don't have 81, don't have 82. So it's only one time, right? So in total, my 8 will appear 8 plus 1 equals to 9 times. So my answer is 9 times. All right, so please make sure you list out by the place values. Okay, and for example, if you see the number 88, count the ones and the tens separately, right? Only consider the ones one at a time, then the tens one at a time, right? Don't mix up. Okay, count by the place values. Hey, it's not 7 plus 1, it's 8 plus 1. Don't forget this tiny little 8 here. Okay, now so many people are already asking, right? What about question 11? What sort of evil is question 11? Right, so let's look at a little story, right? Let's say Angry Psyduck, right? Teacher Yongna's favorite Pokemon. Angry Psyduck tore a piece of paper from a book, right? Hopefully you have your book with you, right? So a piece of paper has a front page and a back page. So every piece of paper actually has 2 pages, right? Every piece of paper have 2 pages. What do you know about the numbers on both pages, right? Should they be both odd? Should they be both even, or one odd and one even? A, B, or C? Answer me. Right, the 2 numbers on each side, please type in the chat. Is it both odd, both even, or one odd, one even? Okay, so I see a lot of people are typing. Good. Okay, so it's actually one odd, one even. Reason being, the two numbers on each side must be consecutive. Right? It must be consecutive. If your front page is odd, the back page must be even. Right? Good job. Right? So if your front page is odd, back page is even. So it must be one odd, one even. And they must be consecutive. Okay? Let's see how this helps with our next question. This should be page 218, I believe. Or is it 208? Okay. Now, a piece of paper in a book is torn off. Again, when you see a piece of paper in a book, one piece of paper has how many pages? Right, one piece of paper actually has 2 pages. Okay, so let's say that 2 pages are gone. When Cindy adds the remaining page numbers, the sum is 797. Take note. 2 of the pages are missing. I have 2 missing pages, right? It's 797 for the remaining pages. Given that the book has 40 pages in total before it's torn, which 2 pages are missing? Okay, now you have 40 pages, but you don't know which 2 pages are gone. You only know the sum of the remaining pages is 797. Do you think you should test and try one by one? Oh, what if page 1 is gone? What if page 2 is gone? And then you check one by one. Please don't. Please don't. Okay? There is a faster way to do this, right? Which is to assume the whole world is sunshine and rainbows and nothing's wrong with the book, right? So let's assume nothing's wrong with the book. Let's assume the book is complete. If the book is complete, then there will be the 4 pages from page 1 to 40. Right? I have all the pages from page 1 to 40. Then can we find the sum of the pages first? Right? Sum with a missing number is a bit hard. But when the book is complete, the number, or rather the page numbers, are all the numbers from 1, 2, 3, 4, all the way up to 39 and 40. Right, I have a complete sum of 40 numbers. And look, 1, 2, 3, 4, all the way up to 40. All 40 numbers are there. This is an arithmetic sequence, right? Sequence with constant difference, right? Especially since this is all the consecutive whole numbers. So we can think of it as the sum of an arithmetic sequence. Do you remember what are the 3 things I need to find the sum of an arithmetic sequence? Do you remember what I need to find the sum of the arithmetic sequence? You need 3 things, right? Your first term, let's review. Your first term, which is 1. Your last term, which is 40, right? 1 plus 40. And don't forget your number of terms, right? 1 to 40, how many numbers are there? Easy lah, should be 40. But then don't forget to divide by 2, right? Or you can use your rainbow method, right? 1 plus 40, 41. 2 plus 39, 41, right? How many pairs are there? It should give you the same answer, right? So upon calculation, 41 times 40 divided by 2, right? What's the result of your calculation? Right, you can do 40 divided by 2 first. It's 20, right? This is 20. So 41 times 20 is 820, right? So you have 820 as the sum for the complete book. But the book is complete, then it's 820. But now actually the sum is only 797. Why is the sum so less? Why is it 797? Now that's because 2 pieces of pages are gone. Right, so now we can find the missing pages. Right, what is the sum of the missing pages? Remember, there's 2 of them. So it's 820 minus 797, right? Which gives you Ronaldo or Messi. Teacher Yong lah. Okay, so it's not 1841, it's 40 pages. 40 pages, so only 41 times 40. Okay, then divide by 2. Now 820, the complete book, minus away the remaining pages, right? The sum of the missing pages will be 23, right? But 23 is 2 page numbers, you know. You cannot say your answer is 23, because 23 is the sum of your 2 page numbers on a single piece of paper, front and back. So now you need to think of two numbers that add up to 23 that are consecutive. So can you tell me 23 is equal to the sum of who and who? Which two consecutive numbers add up to 23? Right, consecutive means the difference is 1. So maybe you can do 23 minus 1 equals to 22. Right, the difference is 1. So take away the extra difference, then you try to divide. 22 divided by 2 is 11, right? And then you will know that one of the pages is 11, the other page is 12. Right? So altogether, pages 11 and 12 are your missing pages. All right, so with that, that is how you do this question, right? It involves a bit knowledge on your arithmetic sequence. All right, with that, that will be the end today, right? For those who have been eager to know how to do question 11, hopefully I have helped you, right? Page problems is actually not that difficult. You just need to be very careful and think orderly. All right, so with that, this is our end for today, right? I ended slightly late. Okay, thank you for your understanding and for accompanying me throughout. Hopefully this session has been helpful. And don't forget, I'll be posting the post-class practice later. All right, and yeah, if you have any questions, feel free to let me know. If not, then I will see you next week or via the mock test video. All right, with that, I'll see you when I see you again. Okay, goodbye everybody. Any questions, please type in the chat. Otherwise, I will see you in the mock test video or next week. Okay. Can you send the mock test now? Mock test is every Friday, huh? Mock test is every Friday, okay? Although, I'll just keep it on Friday. All right. Bye-bye.